take-home test, yes? So let's go through it. And what you're going to do is we're going to go through the whole thing. And yes, I will indeed grade it put it in the grade book. This is going to be worth 18 points towards a homework grade. Cool? It's up to you when you want to grade. So what I want us to do is, once we are done going through this, does everyone have one? Please get it out if you do. If you don't have one, come see me. But get out that take-home test, and let's go through it. I want you to grade it. So what you're going to do is you are going to grade it and make it out of 18 points. Okay? Yes, you can correct them. Okay. Hopefully everyone gets an 18 out of 18 on it. Well, let's make sure. All right. You are grading this. You're giving me 2 scores. You're giving me something out of 18. I'm going to put it in as an 18 out of 18 in the book. But I just want to see where you're at with it. So, like, be honest. Like, if you miss 6 of them, that would give you a 12 out of 18. But I would still put an 18 out of 18 in the book. But just be honest with me. Does that make sense? Everyone cool with that? Everyone still understand the directions? All right. Let's start going through them. First problem is this. And let's see. Let's take a look what the directions say. Solve each of the following equations. Clear fractions if necessary. Any fractions? Nope. Subtract 12 from both sides. Still with me? And then divide each side by 3. So does that answer good? Absolutely. Can you also have this as an answer? Yeah. Could you also have this as an answer? Sure. I guess you should have a bar above it. Okay. So if you got that, if not, make corrections. Okay, may I move off that one? All right, over here, next problem. We get 10 equals negative 3x plus 5x plus 10. Hang on, I gotta sneeze. It's coming. Yes. Thank you. Thank you. All right. Do I have like terms on this one that I needed to combine first?
Yes.
Yes, I do. These need to be combined together, so it gives me 10 is equal to 2x plus 10. Still with me?
Yep.
I'm going to subtract 10 from both sides, so I get 2x. If I subtract 10, what do I get? 0. So what does x have to equal? 0. No, there is a solution. 0 is the solution. Don't make that error. You don't want to miss a point that way. All right, those are the first 2 problems. Is there anything about those first 2 problems where you're like, dude, I need help? Yeah.
Okay, I got their answer, but I went back and I checked it, and I didn't get 24.
Which one are we looking at? Number 1. So you
I plugged it back in for x.
Yeah, so if you plugged in negative 4/3 in for x, that would give you 3 times negative 4/3 is negative 4. Negative 4 plus 12 is negative 8, or is 8. So 8 equals 8. That works. It's perfect. Cool. But that doesn't mean it's infinite solutions because you get we've solved it and then we took the solution, plugged it back in, and it gave us a true statement. Does that make sense? Okay. Can I move on? Number 3. That's 1, 2, tree. You guys know that. Tree. All right, and number 4. All right. So for problem number 3, I could do it one of 2 ways. I could distribute the negative 2 over the parentheses and then go and solve it that way. Or I could divide each side by negative 2. It's your choice. I'll just take the obvious and I'll just multiply this. So that gives me negative 18. Where do you think that error might be taking place up here?
Switching the sign.
Yeah. Make sure that sign switches with that, okay? And then I'm going to add 18 to both sides. So if I add 18 to 48, do I get
66?
66?
Yeah.
Really? Okay. And then I'll divide each side by negative 12. So I get 66 over negative 12. If you got to that point, you're awesome, but you're going to miss one of the points on this 3-point problem. Why? Reduce it, right? Is it okay if I leave the negative on bottom?
Yeah.
Absolutely. So the negative could stay down there, or you just bring it out front. It didn't matter. Looks like, I think 6 goes into both top and bottom. What do you think? Goes into top 11 times, goes into bottom. 6 goes into 12 3 times? 2 times, right? So negative 11 over 2.
Wait, I got 33 over 6.
33 over 6. You didn't get all the way because 3 goes into both.
Ah.
But good try. You did start reducing it. You just didn't reduce it all the way. Problem number 4. I would multiply both sides by 5 first. Of course, this side is 5 over 1, so those cancel. That gives me 2x is equal to 50. Divide each side by 2. X equals a quarter. Uh-oh, here comes somebody. Everybody hide. Oh, what do you got? Oh, this is good. Let's see. Ian, you here?
Yep.
And Diana, are you here? Okay. This looks serious. Where's Ian? Right there. Thank you. See you guys soon. And Diana's over here. Some fancy note for you. All right. Number 5 and 6. X minus 4. The whole thing is over 5 equals 6. And then this one I get 9 minus 3. X plus 1 equals 27. What should we do about, yeah. Yes. Multiply both sides times 5, okay? I'm going to multiply this by 5 over 1, which is the same thing as 5, and this by times 5. That cancels. Then I can just move x minus 4 straight down, is equal to 30. Add 4 to both sides, so I get x equals 34. Sweet? Here's a question. Big error takes place on number 6. Where do you think that error takes place? Yeah. Yeah, a lot of students will go 9 minus 3 and then distribute 6 over the parentheses. What needs to distribute over the parentheses? Negative 3. So there's 2 oopses that could take place here. Sometimes people will say, oh, well, 9 minus 3, that's 6, then distribute. Nope, that's wrong. Okay? So we need to make sure we distribute the negative 3. So I get 9, stays the same, minus 3x, minus 3, okay, because negative 3 times 1. Combine like terms. These are like terms, right? So it's negative 3x plus 6 is equal to 27. Subtract the 6. What did I do? 21. And that's negative 7. There's another place where people would make an error too. You forget the negative when you divide. Yeah.
I did that.
Don't you forget the negative, the x has to be negative since it's negative 3x?
It is, absolutely. So that's where the error would take place, is making sure you divide by the negative. So positive over negative is negative, so negative 7 more. Look good? Did I do it right? Everyone happy?
Yep.
All right, we're on the back of the front page, right? Does everyone feel good about that front page? I'd say that front page would be, if that was similar to what you'll see tomorrow, that's 18 points so far. Okay? So far. So like if I were grading this as a test, that front page would be 3 points each. So 3 times 6 is 18. Does that make sense? You would have gotten the 18 out of 18? Yeah, baby. Love it. Let's keep it up. So, our goal is make sure we can do all the ones that we know how to do really well, and then get as many points possible on the ones that we're questionable on. So what does that mean? Don't leave problems blank. Those are so easy to grade because it's all wrong. Put some thought into the problem. I bet you, even if you're like, oh my gosh, I'm kind of stuck on this, but I'm going to try to go this way, try it. I promise you're not breaking anything in your brain if you try it. I promise. It's really disheartening when I have students that turn in tests and there's blanks on it. And then they'll try and tell me, oh, this was easy. And then I go and grade it. It's like, yeah, no kidding it was easy. It didn't do anything. Do what? The first one is?
Yes. Yes.
No, there's a solution. Yeah, I'm going to distribute here and here. That's 2a minus 10 is equal to 2a minus 6. I subtract 2a from both sides. That cancels that. That cancels that. Sweet. And then I get 10 is equal to negative 6. And we just solved the big mystery of math because anywhere we have a negative 10, we can plug negative 6 in. Oh, no. This is so untrue. This is false. So we have no solution or an answer. What do you think? Make sense? All right, problem number 8. This seems to be kind of a gimme. I think this is an easier problem as far as this deep into the test, which is great. So we get that. Make sure you distribute that 4 to both. Subtract 12. Can I do that? The tough part is realizing I have a negative now. And dividing by 8. And if you get there, you get 2 out of the 3 points. Why is that? You did not reduce. So what does this equal to?
1/2.
Negative 1/2. Okay? So things I'm looking for on this problem. I'm looking for the thought process. I'm looking for the negative. I'm looking for the reduced fraction. Did you just get here?
Yeah.
Okay. Remind me to unmark you absent.
Okay.
Did you have one of these? Make sense? Feeling good? That's problem number 8, right? Problem number 9. Can I move on?
Yeah.
And I'm not putting the problem numbers up here. Every now and then I get a student that goes, well, what's the circled number 9 mean? That's the problem number. What do you mean? So I don't put the numbers up there any longer because there's numbers and we're working numbers. All right. Where should I start the problem number 9?
It's 5y.
Add 3.
Oh, it's 5y. That's a y right here, huh?
Minus 4y.
Thank you. So subtract 4y. I agree. I like it. So we're trying to get y by itself, so that cancels that. That's y minus 3 equals negative 8.
Add 3.
Adding 3. If I add 3 to negative 8, I get to negative 5.
Yay.
Not bad. I'm on. That was number 9. Get to number 10. Number 10, honestly, is probably the easiest question on the test. And I have so many students that miss that.
Really?
Because they see 9 equals 9. They don't see it as 9x equals 9. And then all of a sudden they say, oh, it's infinite solutions. No, it isn't. Why is that? Because 9 times x is equal to 9, not 9 equals 9. So this one, we got to make sure we divide each side by 9. Reduce x equals 1. That's all it is. But I've seen so often that type of problem is missed, and it's like, oh my goodness. Wow. So I wanted to make sure I put that out there going, please don't miss this. If you're going to miss a problem, miss something that's really a hard problem. Don't miss like that you're like, really? All right, number 11. What did I do? Uh-oh. Someone's talking back there. Give me a hard time. All right, we have that. And then this one. All right. What should I do with this number 11?
Minus x.
Subtract x. Subtract x from both sides. Realize that's the same thing as 1x, correct? So 4x minus 1x or 4x minus x is 3x equals 6.
Divide by 3.
Divide each side by 3, so x is equal to 2. There's our answer. And then number 12 is one of the ones that we have, the fractions.
The ones that we gave.
Right, we don't like fractions, so let's learn how to get rid of fractions. What number should I multiply all 3 terms by to get rid of the denominators? I hear 6. Does everyone agree? Someone might be thinking, but what about 12? 12 also works. All of the factors of 2, 3, and 6 will work if you multiply everything by.
That probably not right.
Yeah,
What?
it's 5 over 6.
Oh, it's 5 over 6. Thanks so much. Oh my goodness. It's a good thing we didn't start it.
Dang it.
Okay, that's 5 over 6, right? Okay. Woo! Man. All right, so I'm going to multiply this by 6 over 1. Everyone still with me?
Yeah.
I'm going to multiply this by 6 over 1. Still with me? And I'm going to multiply this by 6 over 1. And then there's reducing that takes place because 2 goes into 6 how many times?
3 times.
3 times. So what do I have right here? 3n. Does everybody see that? Let me stop there. Does everyone see that?
Yeah.
Is anybody stuck there? All right. Then I'm going to reduce here to that. Yes? What is this now? So bring the plus down. And then here, what do I have?
5.
5 over 1, which is 5, right?
Yeah.
Good. So what does this do? 5n equals 5. Divide each side by 5, so I get n equals 1. And if you do that, all of a sudden you're not worrying about the fractions, which is beautiful. Okay, that page would have been worth 18 points as well. So far we're at 36 points, and we're only 2 pages in. No. You feel okay? Feeling right? All right. 13 through 16. I think I can.
Worth 3 points, right?
What's that?
Is one question worth 3 points?
Yeah, for the most part. For right now, and then later they will start adjusting a little bit more. But for right now. Okay. So I think I could squeeze all these up there. Problem number 13, we want to get y by itself. Agree? Okay. So I want to start doing some things to each side of the equal sign to start getting y alone. So I think the first step is this. What do you think?
I agree.
That's an x. So that cancels that. That gives me negative 4y is equal to negative x
Plus 24.
plus 24. So be careful. Realize that's a positive 24.
Oh, divide by negative.
Divide everything by negative 4. Good. I heard it over there. I like it. I like it. Paying attention to those negatives. Boy, sometimes they come back to bite you a little bit. That'll cancel. Y is equal to
negative 6 plus negative 2x.
2x, not negative, is it?
Yeah.
And then what is this?
I did the 26.
So we heard a couple of people that they goofed the negatives. So watch out for those negatives because sometimes it's going to come back to get you a little bit. Number 14, we want to solve for L. We want to have L by itself. Okay? So I need to start moving things around. What's my first step to get L by itself? Subtract 2w. I like it. So I get a minus 2. Oh, man. Hang on. I made a mess. A minus 2w equals what?
2L.
Equals 2L.
Divide by 2.
Divide everything by 2. Good.
It's
5.
So I get L equals. Do you think I could leave that?
No.
This is actually okay.
Why would you?
Well, you can
Well, yeah. I think this is an okay for right now. But what it's really going to work down to is this. What is it? 1w. How's that? So I want to leave that like this for right now. But I'm going to circle this part right here.
Wait, well, why
Yes. But I want you to see this. This is what's taking place. A over 2 minus 2w over 2. And then that comes down to that by reducing it.
Can we do 0.5a?
I like 0.5a. That's good. I'll go with that.
Wait. So that's alright?
So I would take, as far as this quiz goes, I would take something like that for an answer. The most correct answer is getting it down to this, which would be the equivalent of 0.5a minus w as well. So, but just start thinking as you're working these problems. Sometimes they could go a little bit further to reduce them a little bit better, but someone's singing. All right. This next one, we want to get that by itself, right? And I heard multiply each side times 3. I like that. That gets rid of that denominator, right?
Yeah.
And that's 36 is equal to x. Whoa. Time out. 36 is equal to x plus y. I want y by itself, so how do I undo x? Not divide, it's subtract it.
Y equals 36.
So y is equal to 36 minus x. I like it.
Yay.
Oh boy. Oh boy. All right, eyes up here, eyes up here. I have a y here, I have a y here. What special thing did we start working on in this?
Divide
Yeah.
by
Undistributing.
Undistributing. Okay, so they both have a y in common. I cannot add them together because 5xy and 10y are not like terms because this has an x involved. So I'm going to factor out, I'm going to undistribute. See what I did? Now think about this. Think about this before you ask. Y times 5x is 5xy, yes? And y times 10 is 10y, agree? So all I'm doing is I'm just realizing, oh, these two terms I have a y in common. If I pull that y out front, that's going to be undistributed. Now I have y times this quantity. So if I divide both sides by the whole quantity, so my answer is going to come out to y is equal to 1 over 5x plus 10.
What was I doing on this problem?
I don't know. Other things you could have had for an answer, you could have had 1/5 x plus 1 over, no, never mind. Just look over, someone who's at the door. Bless you, yes, sir.
You have divided by 5x.
Do what?
Divide by 5x.
Divide by 5x. In the original part? If I divide by 5x, that would give me y, and then that would give me 2y over 5x, or 2y over x. So that kind of, you would start getting that way, but I think you're making it more complex than it needs to be.
I got 27.
So that page would be worth 12 points. Why is that? 4 problems, 3 points each. Got it?
Are we gonna have any of these other tests?
Let's just get
Yeah.
down stage.
These are easy. I'm gonna fail these.
No, you're not. That's why we're going over it, because you're going to.
I know, but we only have one like that.
It's only one, yeah. I bet you one.
Um,
But I'd say make sure that you at least get a start on that one so you can get a couple points. You know, it's better to get 2 out of 3 points than 0 out of 3. All right, so let's take a look. So let me put the So where does the mistake look like it took place?
In the very beginning,
they added
you have to add a 2x and 3x.
So what should we have probably done to this problem? What should have been? Yeah, I should have combined these like terms to give me this, and then I should have combined those like terms to give me this. That's what we should have done. So realize the adding of 2x did not take place on either side of the equal sign. It took place on the same side. So that was the first mistake. Then if you start to go and solve this, subtract x, that cancels that. So I get 9 is equal to 3x minus 18. Add 18. So x is equal to 9.
Why?
Right?
I had to add x. For some reason, I had to add x.
That's right. You know what I'm telling, bro.
What'd I do?
I had to add x for some reason.
Tell him, Leo.
What? What'd I do?
I think it's just him.
Wait, what? Wait, time out. Something happened. Did someone get confused?
Yeah.
Are you good?
I had to add x for some reason.
You,
So I subtracted 3x. So I subtracted 3x from 2x. And then I got 9 minus x.
oh, you made an arithmetic error on that. So do you feel okay that if I combine this and this, I get 1x?
No.
Yeah.
Isn't that 5x?
No.
3 minus 2.
Oh, never mind.
Because you got that right there, right?
Yeah.
That makes sense?
Yeah.
Yes, thanks for your patience.
Could you add 2x instead of combining like terms?
Oh, okay. So here, let me put this. So could I have added 2x to both sides like that?
That's what I did.
That, you know what? That's going to take you to this. Does that agree?
Yeah.
And then you could have, I don't know, subtract 3x. So that's 3x minus 18 equals 9. Add 18. Add 18.
27.
That's 27 is equal to 3x, so x is equal to 9. Yeah, that also worked. So what their first move was by adding 2x was appropriate as long as I do it to either side of the equal sign. Okay? It's pretty disrespectful. Checking messages in my class. I'll take your phone next time. Cool? Number 18. Last problem. Ron, were you okay with that one problem?
Yeah, I'm fine.
You saw your mistake? Okay. All right.
Wait, hold on.
He added the six.
Hold on.
You guys okay with that? Do you see the error right away?
Yeah.
What happened?
Yeah.
Yeah, he added 6 and 3 together to get 9, which in your mind will automatically click on, oh, that's it. But then you have to realize that the PEMDAS, you're right. You have to distribute first. But I tell you, sometimes when you see an error that takes place, it's real easy to make your mind grab it saying, yep, that's it. That's the error. Okay? So we got to make sure we distribute first. So that 6 needs to come straight down. Plus 3x minus 18 is equal to 18. And then combine that and that. So I get 3x minus 12 is equal to 18. Add 12 to both sides. So that's 30. And then I get x is equal to 10. Again, where they made the error was they combined those together first. Don't do that. But sometimes when you see an error take place, it's like, oh yeah, that worked. That worked. Yeah.
Wait, well, how many points was it for the last page?
I would have said probably 3 points each as well. So 6 points. So what do we have? 18 and 18, that's 36. 36 and 12 is 48. 48 and 6 is 54 points.
So is that how many points the test is gonna be?
I would say the test is going to be pretty close to about what this is. Not much greater, not much less. Okay? So, yeah, if you would, do me a favor, let's just take care of some stuff. What I want to do is I want to go through. Ready? Here we go. Yeah. Another problem like 16, you say? Ladies and gentlemen, class is not over. Okay, we wanted another problem like number 16. So I'm going to put number 16 like this. Okay, that is because we are referring to that question number. This has nothing to do with the numeric value of any part of the problem. Got it? All right. No,
We're just kidding. Chill out.
okay. So, shh. Okay, this is very similar to number 16, but what is one thing I have to do first before I reverse take out? Yeah, take that, subtract that 6 from both sides. So I just wanted you to see that first because I would hate for me to have a little curveball and all of a sudden you're like, but wait. Because you can't factor an x out of something that doesn't have an x. Okay? So now, we need to understand that we have an x here and I have an x here. Agree?
Yeah.
So what I'm going to do is I'm going to undo the distributing of x. I'm going to undo. So this and this, they're both going to come out and I'm going to create parentheses after that. Okay? So what is my first thing that goes here? 7y. Where did the x go? It got factored out of it. We took it out of it. And then what do I have here? Plus what? Plus 12. Okay? So let's make this all work. Let's make this work. Okay? Things that we have to understand about this type of problem. If I redistributed that here and here, x times 7y is 7xy. That's what we had. X times 12 is 12x. That's what we had. So we just pulled it out and created parentheses for it. So we are solving the problem as is right now. So now I have x times this quantity, and if we were trying to get x alone, I have x times a quantity. How do I undo x times a quantity? Divide by a quantity. Thank you for using my words. I like it. Okay? So I'm going to divide each side by this quantity. Okay? So that's going to reduce here and here. So I get x is equal to 2 over 7y plus 12. And I don't think there's any reason to go much further than that. That's the toughest problem you're going to see. Okay? And it's using that little tiny property that I'm just kind of throwing in there. You know, and other ways of thinking about this problem is, what do I have in common between these two terms? Can I pull something out and create a parentheses about it? Okay? That's definitely something. That's what was asked for. Whoever asked for that problem, do you want to see another one like it, or are you okay? Anyone else want to see another one like number 16?
Can you do number 12? Please?
Number 12? Okay, but does anyone else want to see number 16 redone?
What was the answer?
On our original one? Oh, shoot.
It was, hold on. Number 16 was y equals 1 over 5x plus 10.
That's it, yeah. Does anybody else want to see one like number 16 again? We all right? Okay. Number 12, was that what was asked for? Okay. Number 12. Okay, so this is going to be similar to number 12. I'm just putting this up here so we know which number this is referring to. So let's create x over 7 plus x over 3 equals
6 over 21.
I was thinking about that, but
4 over 21.
all right. Well, I think 4 over 20 would be, or 6 over 21. Either way, it'd come out right. All right. So what? So we have all three have fractions. Agree? We have a denominator. I have numbers of 3, 7, and 21 as my denominators. So what do you feel I should multiply all three terms by to get rid of all three denominators at once? 21. Feel okay?
Yes.
Okay. So I have, this is going to be 21 over 1. This is 21 over 1. And this is 21 over 1. Okay? So if we reduce, 7 goes into 21 how many times?
3 times.
3 times. So what do I get right here?
3x.
3x. Does everyone see that?
Yep.
Then I have, this goes in there, plus 7x. Is that all right? Equals, oh, 21 goes into 21, so that's just equals 4. Is the problem done? No, the hard part's done. So then I combine those together. It gives me 10x equals 4. So x is equal to 4 over 10. Uh-oh. What's 4 over 10?
2 over 5.
2 over 5. And that's what x is equal to. Sweet. That's definitely the type of problem you might see. What else? What other problems would you like to see?
Wait, I thought that was
Go ahead.
Okay. Something like the last two.
The last two. Where there was a mistake that was made?
Yeah, I found the mistake, but then I did it wrong. So.
Oh, okay. I would say the best way to work number 17 and the best way to work number 18 is ignore the work that's there and just do the problem. Because we're going to have a mistake thrown in there. So it's like, let me work it out first. And then once you work it out, because the hard thing is sometimes if I'm planting a seed of mistake that's there, I goof up. Okay? So, so as far as number 17 goes, just working it out, which was this, right? So I'm not trying to have any mistakes up there. Are you okay with combining like terms? Each side has like terms with it right away. Are you okay with that?
Yeah.
Okay. So this is a like term and this is a like term. Agree? You spend more time doing other things.
No, my pencil fell. I have to
I saw it. I saw how it
All right. So 3x minus 2x is what? 1x. Is 1x the same thing as x?
Yes.
Okay. And then this is a like term as well as this. So what do I get there? So I get 4x minus 18. And then solve it from there. So there was already like terms that took place. They make the error with the like terms in the first one. You want to do that now? Yeah, that'll work. So that gives me negative 3x over there. That cancels that, equals negative 18. Subtract 9, subtract 9. So I get negative 3x equals negative 27. So divide each side by negative 3. X equals 9. Okay. Still going to get you there. There's a lot of different ways of going through it. And you know what? Everyone's mind works a little different, which is awesome. That's how it's supposed to be. Cool. I like it. Is that all right?
Yeah.
All right, so let's just talk about some strategies for tomorrow before we get out of here. Okay, it's almost time to go. What would be a good way to go through this? What, like, do you feel that you have studied enough and you go home tonight and you're like, forget it, I'm not doing anything? Some of you might. That is a reality. Does that have enough for you for this test? I don't know. It might. You might be 100% ready for this. There's a couple of you that I feel pretty confident that I can say, hey, you know what? Ditch third period, take the test right now, and you're going to nail it. I feel pretty confident with that. Okay. Then there's some of you that I think that if you were just to maybe just go through the video a little bit, maybe fast forward to the parts that you might need, like, because you know on your sheet what you missed, right? You might want to just go through that and take a look at it. Okay? Feel comfortable about it. If you find that you might have had a couple questions for tomorrow, come find me. You know, just go over to Showing Law right before school because that's where my med class is. If you have a couple questions, let's go over them. Or meet me in my office if you're off first period. Or if you want to sometime throughout today, meet with me. Come over to my office right over here, 439A. If it's 7th or 8th period, come see me over in the Career Tech Ed building, which is office 200. Okay?
Is that past like Silver Bowl?
Yeah. Well, even with Stutler Bowl. Get to the picnic tables by Stutler Bowl, going through the side door.
Oh, I know.
7th, 8th period. Yeah.
Does it have like a square and then
Yeah. That is us. So those are just some things for you. So you study as effectively as you feel. I think you're ready for this test. Okay? We good? Yeah, clear the way. We have somebody with a boot on.